Hi, my name's Diane, and I'm applying for the Science Ambassador Scholarship. My question for you today is, why does ice float on water? When you get a glass of water and you put some ice in it, you notice how the ice floats on top. But have you ever questioned why? Well, today we're going to look at the periodic table of elements and the different phases of matter to try to understand why ice floats on water. This has to do with the small-scale interactions that occur on an atomic level that produce these macro-scale effects. So, we have different phases of matter. Three common phases of matter are solid, liquid, and gas. These phases of matter also have different densities. Density has to do with how heavy an object is compared to the amount of volume that it takes up. So, in a gas phase, the atoms and molecules actually have a lot of energy, so they're moving around really fast and they take up a lot of space. In a liquid phase, they have less energy, so they move closer together. In a solid phase, they actually pack really tight and close together, so they take up very little space, but they still weigh the same. This makes solid way more dense than a gas phase and a liquid phase. So we would expect that when water turns into ice and freezes, the ice should be more dense than liquid water and therefore sink to the bottom of water. So the next thing that we're going to look at is the periodic table of elements, which organizes atoms based on specific trends. In water, we have H2O, which means we have one oxygen and two hydrogens. So we're going to actually compare the electronegativity of oxygen and hydrogen. Electronegativity has to do with an atom's affinity for a negative charge, or electrons, basically how bad it wants a negative charge. If we look, oxygen is over here on the periodic table, and hydrogen's over here. This means that oxygen is way more electronegative than hydrogen and wants to pull all of the negative charge towards itself in a molecule. So here we have a water molecule. We have our one oxygen and our two hydrogens. If we look closely, we see that the oxygen is going to pull electron density towards itself. This actually makes the oxygen now partially negative, and our hydrogens therefore become partially positive because of the lack of electron density around it. Now, if we look at two water molecules interacting, we see that the partial positive end of one molecule can actually be attracted to the partial negative end of another molecule. This is known as hydrogen bonding, and it's a type of intermolecular force, meaning it's a force that occurs between two different molecules. So, because of hydrogen bonding in ice, the molecules align themselves in this lattice structure that takes up more space than water does. This makes ice less dense than water. It's pretty fascinating because without it, ice would sink to the bottom of lakes and oceans in the winter, and eventually all of the water would freeze up. Floating ice sustains life underwater. So, thanks to chemistry, we can understand why something so simple as ice floating on water actually works. Once again, my name is Diane, and thanks for watching.